Hello and welcome to this video on enhancing DataMiner AI with human feedback. Now, as the title suggests, we will be talking today about AI inside DataMiner. So let me start by giving you a small overview of what AI features we have available inside DataMiner. We also sometimes call them augmented operations features, and this is by now a collection of 9 features that you see here that all use state-of-the-art artificial intelligence or big data techniques. And these features, they do things like detecting certain issues or certain potential issues in your system that are either there now or that might develop in the near future. They can help you with your configuration in some cases. They can highlight certain data over others, and so on. And they do all that in the hopes of making you more efficient as a daily user of DataMiner. So assisting you in your daily operations with DataMiner. Now, in this video, we will be talking about 2 of those features. On the one hand, behavioral anomaly detection, and on the other hand, proactive gap detection. Now, these 2 features, they will detect certain issues in your system based on the trend data that you monitor with DataMiner. And we will be talking about what these features can detect, but then also how we can use feedback or how we can give feedback to DataMiner to improve the detections that they make. And the reason we sometimes need that feedback is that based on the trend data alone, that is sometimes not enough information to determine whether something is an issue or not. That often also depends on the broader context, how you use the devices that you are monitoring with DataMiner in your organization, what procedures you have in your organization, and so on. And that is why we implemented this feedback mechanism to give you an easy way to learn DataMiner, to teach DataMiner how, what kind of things are issues for you and what are not issues. And then hopefully DataMiner will learn from that and improve the detections that it makes. Now, before we start, we will be deploying a catalog package from the DataMiner catalog. So join me in going to the catalog.dataminer.services, here, this address, catalog.dataminer.services. And then you can search for enhancing DataMiner AI with human feedback. Here, this package, and then hit deploy to deploy it on the system where you will be following along on. I already deployed this before I started recording this video, so I will not deploy it now. But once you have deployed this, you will find some elements in your DataMiner system under DataMiner Catalog, Empower 2025, Enhancing DataMiner AI with Human Feedback. And these elements are the elements that we will be using to demonstrate certain things throughout this video. All right, now let's start with the first feature, behavioral anomaly detection. It's a bit of a complicated name, behavioral anomaly detection, but if you analyze it, it actually describes what it does. And that's why I like this name actually. So what this feature does is it detects when a single metric in your DataMiner system behaves in an anomalous way. And anomalous meaning weird or unexpected. So it will monitor all your trended parameters inside DataMiner, and it will make a model for them based on the historical behavior. And when a parameter deviates from that historical behavior based on the model, it will notify you about that. Now, to give you an idea of what kind of things it can detect, let's look at an example. So for that, we can go to our DataMiner cube to the element audio bitrate. So this element, it simulates several audio channels that are being transmitted over a certain connection. And for each channel, we monitor the bitrate. Now, let me go to the first bitrate here. I will open the trend graph by clicking this icon here. And let me zoom out a bit. And as you can see, this bitrate, this used to be stable for a very, very long time. And then recently, it jumped down and it started to deviate a bit more from its average, as you can see here from the light blue area. Now, this is typical behavior of a bitrate that changes from a constant bitrate encoding to a variable bitrate encoding. And in some cases, that can be interesting for an operator to have a look at, because this might indicate that something is wrongly configured on the system, or maybe that a wrong file is being transmitted, or something like that. Now, DataMiner also detects this change, as you can see here from these black squares at the bottom of the trend graph. Let me zoom in a bit so that we can see it a bit more clearly. Now, these two squares, they are anomalies that are detected by this feature behavioral anomaly detection. And there are two anomalies here detected. There is the big one, which is a variance change, and this corresponds to this bitrate becoming less stable. Yeah? There started to be more variability. It started to jump up and down more than it used to. And then here it's a bit hard to see because it's overlapping, but there is also a level shift. And this corresponds to this jump down that we saw on the trend graph. So DataMiner detects that this parameter changed behavior and that it deviated from its historical behavior. And you can see it in the trend graph, but you're most likely not looking at your trend graphs all day. So you can also find these detections back in the alarm console. And to find those, let's go here to this light bulb on the top right of the alarm console. It is now blue, so it means it detected something. And if you click this, you can see here an item, 3 anomalies were found in your trend data. And if you click that item, then a new tab will open in your alarm console called the Anomalies tab. And in that tab, you can find all the anomalies that were detected in your system. I have 3 now here, but it might be that if you have other elements on your system, you might have more or less anomalies that are detected. Now, here, the first 2, those are the ones that you also see on this trend graph. The third one is on another element. And as you can see, it's indeed also a variance increase, yeah, a variance change, but then it increased, and a level decrease. So that's a level shift, but a jump down instead of a jump up. All right. So these kind of things are the things that behavioral anomaly detection detects. So let me go back to my slides. So behavioral anomaly detection, it runs out of the box on all your trended numeric parameters, and it monitors those, and as soon as it detects something, you will be notified about it, both in the trend graph and in the alarm console. And it runs in real time. Now, to avoid a bit of confusion, there is also another feature that has a very similar name called relational anomaly detection. And that feature detects or monitors multiple parameters together and monitors the relation between those parameters. And it will detect when this relation no longer holds. Whereas behavioral anomaly detection only runs within a single parameter. So what they do is somewhat similar. They are both cases of anomaly detection, so detection of weird behavior, but they monitor for something slightly different. Now, relational anomaly detection is about the relation between parameters, so it monitors multiple parameters together. So think, for instance, of a main channel and a backup channel. Yeah, you normally expect them to be more or less equal. If that is no longer the case, then relational anomaly detection can detect that. And behavioral anomaly detection, the feature we will be talking about today, only looks within a single parameter and compares the behavior of that parameter with its historical behavior. And it can detect things like we saw here on this audio bitrate parameter that jumped down and that started to become less stable. Relational anomaly detection is the topic of another video that you can also find on the internet. Now, let me go back to my example. If you look here at the level decrease that was detected on this audio bitrate parameter, and you look here at the numbers, then you can see that there was indeed a jump down, but it was a very, very small jump down. It jumped down from, here in my case, from 96.01 kilobits per second to around 95.96 kilobits per second. So that is a very, very small jump down. Now, the reason why DataMiner detects this and marked it as anomalous is because this audio bitrate parameter used to be even more stable before. So it was the first time that it saw something like this, some jump like we saw here. Now, if you're an operator, it might be the case that you say, well, this jump, it's actually too small for me to worry about. So I don't want this detection. I don't want to have it in my anomalies tab because I'm not interested in it anyway. Now, you can give feedback to DataMiner that you are not interested in this, and then DataMiner will learn from this over time and will not create detections like this anymore. And for that, we can go here to the right-hand side in this column with the thumbs up and the thumbs down, and we can hit the thumbs down to tell DataMiner we don't like this detection. Now, you will need to repeat this a few times because DataMiner is a bit conservative. It will not change its behavior based on one instance of feedback. So that is a first small exercise that I have for you. I want you to go to this audio bitrate element, and there's a button there, generate channels 2, 3, and 4. And this will generate similar data on channels 2, 3, and 4. So there you will also have a variance change and a level shift. And I want you to give negative feedback on all the level shifts. Yeah, they are all level decreases in this case because it jumps down. So I want you to give negative feedback on those. And then I want you to press the button generate channel 5. That will also generate the same data on channel 5. And there you will see that no level shift is detected anymore, only a variance change. So I will give you a few minutes to complete this exercise. You can pause the video in the meanwhile, and when you're done, come back. All right, if you've completed this exercise, congratulations. Let's also do it together here in the video. So I will go to this element outside of the trend graph, and I press this button, generate channels 2, 3, and 4. So as I said, this will generate similar data on these channels 2, 3, and 4. So you will also have level decreases and variance changes. Let me sort to get a better overview. And then for all the level decreases, I will give a thumbs down. All right. And now I generate data for channel 5. And then here you see that only a variance increase is generated and no level shift anymore. Now, you can also see this on the trend graph of this channel 5. So, as you can see, this variance change is still detected, and it's still a black square under the trend graph. Now, the level shift is also still generated, as you can see here, but it is indicated with a gray square. That is because DataMiner still detects this as a change in behavior, what we call a change point, but it is no longer marking this change point as anomalous because we gave negative feedback to very similar level shifts on other audio channels. So that is why it's indicated as gray here in the trend graph, and we don't have an anomaly in the anomalies tab in the alarm console. All right, now let me clear out these suggestion events here. This doesn't do anything special, but just allows me to start from a clean alarm console again. So I will press here, clear alarms. Now, let's look at another example, and let's go to this task manager element here. So, as the name suggests, this task manager element will simulate a Windows task manager. So there will be a number of processes that we simulate here. And then for each process, we will also simulate the memory usage. And there is a button here, generate data. And every time I press that button, a new process will be created in the table above, and some history will be loaded for the memory usage. Now, in the previous example, we used only negative feedback to get rid of certain anomalies that we didn't want. Now here we will use both positive feedback and negative feedback, and we will do that to tailor what kind of anomalies we want to detect and which we don't want to detect. So Let me start by generating data for the first process. And again, you can follow along. So here I generate data. Now it's generating data for the Google Chrome process. It takes a little bit, but as you can see, it generated the data now. And I will have a look at the trend graph by clicking this icon here. And as you can see, the memory usage of Google Chrome used to be quite stable, but then recently in the last hour or so, it's suddenly jumped up. And that jump was detected as an anomaly. Now, I didn't say this yet, but note that this event that is shown in the alarm console is not actually a real alarm. It is what we call a suggestion event. So you can find it in this separate tab, this anomalies tab, but you can't find it in the active alarms tab. And the reason behind that is that these events are detected automatically without you configuring anything except for trending the parameter. And yeah, we wanted to make a distinction between these things that are detected automatically and the things that you explicitly configure. Now, you can also make this into an actual real alarm that is also shown in the active alarms tab. And for that, you will have to configure an alarm template on the element. So let me do just that. I will right-click here the Task Manager element, then go to Protocols and Templates, Assign Alarm Template, New Alarm Template. And then I will give this a name, Alarming on Anomalies. Okay. Now I will monitor this parameter here, the memory usage parameter, and then I will go all the way to the right, and there is a column called Analytics here, and in that column there is a button. And if I click that button, a pop-up will open with settings for anomaly alarms. Now, in general, this pop-up contains more settings than only for anomalies, as we will see later with proactive gap detection as well. It contains all settings for all augmented operations features. Now, here we are only interested in the anomaly alarms. And more specifically, we want an alarm for this level increase that we saw on the Google Chrome process. So I will check this checkbox here, and that will make a real alarm instead of a suggestion event for all level increases that are detected on this Google Chrome process. Or, sorry, on this is the parameter, so all the memory usages of all processes on this Task Manager element. Note that there is a drop down here which says Smart. For now, I will leave it on Smart, but in a minute we will see what it does on other options. So, all right, I will close this, and then I press OK. And as you can see, my suggestion event has turned into a real alarm, in this case of severity minor. And you can then also find it back in the active alarms tab here. All right, let me go back to my anomalies tab. Now, this jump, this is rather big. So personally, I like this one because, yeah, I want to be notified about detections like this. So I will give a thumbs up on this one. Now, let me go back and generate data once more for another process. This time it will generate data for the Java runtime process. And as you will see, the data will look very similar, but the jump is much smaller on this one. Now, it's still detected as an anomaly here, and it is made into a real alarm because I configured it like that in the alarm template. But personally, yeah, this jump, it's only a jump of a bit less than 50 megabytes. I don't consider that particularly a particularly big jump, so not very interesting. So I will give a thumbs down on this one. Now, note that next to my thumbs down button, there is a light bulb here that appeared. It was also there in the previous exercise, but there I ignored it. But now let's have a look at what this light bulb does. Well, in general, this light bulb shows you actions related to the feedback that you just gave that might be interesting for you to do next. And in this case, it suggests to improve your alarm template. So I will click this, and then the same pop-up opens as we saw before. But now it has another configuration here. Note, this drop-down used to be smart, now it says absolute, and this means that DataMiner suggests to alarm based on an absolute threshold. So it will still create alarms for the level increases, but only if the size of the jump, the absolute size of the jump, is bigger than 200 megabytes. Now, how did it arrive at this 200 megabytes? Well, we gave a thumbs up on a big jump and a thumbs down on a small jump. So it took a size somewhere in between there, and it put that as a threshold. So if I accept this one, the anomaly where we gave thumbs down on will disappear, and the ones where we gave thumbs up on will stay. Right? So Java runtime disappeared, Google Chrome stayed. Now, I have another exercise for you. So I want you to go to this element and again press generate data once more. And this time it will generate data for the Microsoft Visual Studio process. And as you will see, this is a big jump, so there is an anomaly generated for this data. But if you know Microsoft Visual Studio, it often uses a lot of memory. So in relation to like the normal memory usage of Microsoft Visual Studio, this one is actually not that, that significant. So that is why I want you to give negative feedback also on that one. And then I want you to press the light bulb and see what alarm template suggestion DataMiner has for you. Again, you can pause the video and come back in a few minutes to complete the exercise. All right, welcome back. Let's have a look at what we did on the exercise. So you can press generate data once more. This will generate data for the Microsoft Visual Studio process. And there is a big jump here of more than 200 megabytes, so an alarm will be generated. Here, it's a jump of 400 megabytes. But, yeah, Microsoft Visual Studio uses a lot of memory, so, yeah, I mean, in relation to the normal memory usage that it has, maybe 400 megabytes is not that significant after all. So that is why I will give negative feedback on this one. And now again, DataMiner has a suggestion for the alarm template. So I press the light bulb icon and improve alarm template. And what it now suggests is to alarm level increases based on a relative threshold. And what does this mean? Well, it means it will still alarm level increases based on the size of the jump. But now it will look at this size relative to the point where it started from. So that means that if you have a jump, for instance, from 100 megabytes to 150 megabytes, then this is an increase of 50 megabytes. So in relation to where you started from, this 100 megabytes, this is actually an increase of 50%. And 50% is more than the threshold that it configured there of 40%, so that one will be alarmed. However, if you would have the same jump from 200 megabytes but then to 250 megabytes, so again a jump of 50 megabytes. So that's the same absolute size of jump, but in relation to, or relative to the value where it started from, this 200 megabytes, this only represents an increase of 25%, which is lower than 40%, so that one would not be alarmed anymore. And again, it took this threshold based on the feedback that you gave. So it took something such that the anomalies where we gave positive feedback on would still be alarmed, but the anomalies where we gave negative feedback on would not be alarmed anymore. Now, there is also a little trick that I want to show you. Here there is this clock button, and this button allows you to show the current configuration of your alarm template and compare it with the proposed configuration. So if you click this, it will show the currently configured configuration for level increases. So that's the absolute threshold of 200 megabytes. And if you click it again, it will show the proposed configuration. All right, let me apply this alarm template, and then you will see that the level increase on Microsoft Visual Studio disappeared, but the one on Google Chrome stayed, as we expected. Now, there is one more thing that I wanted to tell you, and that is about the scope of the feedback. Now, if you have multiple users on your DataMiner system, then all of these users, all of the users that can see the same alarm or the same suggestion event, can give feedback on that suggestion event. So that means that if you are on the same system as me, you can give different feedback on the same suggestion event than I can give. But whether to create an anomaly or not is a system-wide decision that DataMiner has to take. So when it takes that decision, it will have to aggregate all the feedback from all the users, take a certain kind of average, and based on that, it will decide either I make an anomaly for this thing that happened or I don't make an anomaly. And similarly, for other instances of the same parameter on your system, they will also, or let me say differently, so if you have multiple instances of the same parameter on your system, well, it will take into account all the feedback that you gave on all these instances of the parameter. Yeah, for instance, if you have a table column, like we have in our examples, well, then feedback that you give on one cell of the same table column will also have an influence on the anomalies that are detected on other cells of that same column. But also, if you have multiple elements with the same protocol, then feedback on a parameter on element A will also have influence on the anomalies that are detected on the same parameter on element B. And so DataMiner will aggregate all this feedback of all users and of all instances of all instances of that same parameter that are available in your DataMiner system. And based on that feedback, all that aggregated feedback, it will decide either I trigger an anomaly or I don't trigger an anomaly. All right, and that is all I wanted to tell you about behavioral anomaly detection. So let's go to the next feature, proactive gap detection. Again, I will explain what this feature does, and then we will have a look at how we can use feedback to improve the detections that it makes. And to give you an idea of what it does, let's start with an example here on the content management servers view. So what I show there is I show a problem that I had a few days ago with a website that I host. So I'm hosting a rather large website on 3 different servers, and it has quite some content. And each of these servers has a cache to serve this content quickly to the user when a user opens the website. And that means this cache, this has a certain size throughout time. And here on this graph, I monitor this cache size of all the 3 servers over time. And you can see that this cache size behaves a bit differently depending on the server. So there is the blue server. First of all, that's the first one. You see there the cache size, it periodically goes up and goes up quite high, but it never reaches 100%, and then it goes back down again. So because it never reaches the maximum cache size, this one actually runs fine. Similarly, the third one, this one has a fairly stable memory usage, and it's always quite low. So that one definitely has no problem. The green one, that's my second server. Usually it's also fairly stable, but a few days ago something went wrong in the cleanup of the cache. And the cache size started to grow quite rapidly, and before long the cache size was at 100%, so it was completely full, and my website started to run slower than it usually would. And yeah, I want to avoid this, so I would actually have liked DataMiner to tell me that this green one, this green cache size was going higher than it normally was, and that it was continuing to rise, and that it was going to hit 100% before it actually did so. Now, DataMiner is a complicated piece of software, so no doubt there are many ways you can try to detect this, but many of them are somewhat cumbersome. For instance, an obvious one is you could say, well, make an alarm template on the cache sizes here. And yes, you can do that, but because the behavior of the cache sizes is somewhat different between the different servers, this is actually a little bit challenging. If you want to make one alarm template for the 3 cache sizes, then if I also want to avoid that the blue one has false positive alarms, because the blue one actually is not causing any problem, so I don't want alarms on that one, then I would have to put my threshold quite high here. And if I do that, then would mean that it would take quite long before an alarm is generated on the green one. And that would leave me not that much time anymore to fix the issue before it actually causes a problem for my website. You could, of course, say, well, make an alarm template specifically for the green one, and that could work, but creating alarm templates for every server separately, that's quite a lot of work, so we also want to avoid that. And as you might imagine, there is a solution using this feature, proactive gap detection. And to see that, let's go here to the tab Before Failure. So this shows the same data, but a few hours before the green one actually reached 100%. So you can see here, the blue one and the green one, they are going up. And we know from the previous one, the green one will continue to rise, but the blue one will stabilize and slowly start going back down. Now, if you look at these parameters on this trend graph, on this window, you might actually miss which of the parameters is actually the problematic one. Because the blue one and the green one, they look very similar. And based on the history, we actually know that the blue one will likely flatten off and start going back down very slowly, while the green one will not. But on this trend graph, you don't even see it. So if you have an operator looking at this trend graph, he might also miss it. Now, there is a way to make a distinction between the two, and that's here on the right-hand side. Let me pan a little bit so that you can see it better. So this dashed line here on the right-hand side, this is the trend prediction that DataMiner Analytics module makes of these parameters. And that is based on the historical behavior of the parameter, and it correctly identifies that the blue one will likely stop rising and stabilize and then slowly start going back down, while the green one will continue rising and will soon hit 100% here, as is also indicated here by this yellow triangle here. And note that this is actually what we wanted to detect, right? We wanted to detect that the green one was going to hit 100% before it actually did so. So that is what we wanted. Now, again, we are probably not looking at our trend graphs all day, so you can also find this detection back in your alarm console, and you can find this back again in this light bulb icon here. So if you click this, there is an item which says 1 alarm is predicted in the near future. And if you click that item, this will open a new tab called the Predicted Alarms tab. And this contains all detections like this, where a parameter will reach a certain threshold in the near future. And these detections, these suggestion events that are shown in this tab, they are made by this feature, Proactive Gap Detection. And here you can indeed find the one that we were looking for, right? This is a predicted maximum value of 100 of the cache utilization on my CMS server 2. So this is the detection that we want. And this is what proactive gap detection does. So what it does is, in the background, it makes a prediction of all your, again, your numeric trended parameters. So you don't have to configure anything. And it will notify you when a metric crosses a certain boundary in the near future, or will cross a certain boundary in the near future. And if that is the case, it will make a suggestion event, or an alarm if you configure it, in the Predicted Alarms tab in your alarm console. Now, proactive gap detection notifies you when the metric will cross a certain boundary. Well, which boundaries? Well, in the example here, this was actually just the range limit that was defined in the protocol. So remember, it was a percentage parameter. Yeah, the cache size was expressed in percentages. So a percentage goes from 0 to 100%. 100% is the upper range. And proactive gap detection knows that that is the upper range and notifies you if you're going to hit that upper value of the range. Now, these range limits, they are nice because you don't have to configure them, but they aren't always completely up to the task. And to see that, let's go to another example here. I will go to this element SFP monitor. And this element simulates a small form factor pluggable. So this is a device that is typically used to connect a fiber optic cable to a network switch. And through that cable, there is a signal that runs, and that signal that has a certain power. And that is what we are monitoring here. Here, the optical RX power. Now, let's have a look at this one. And it has quite a lot of history, so we will zoom out a bit. We will go to month to date here. And even then, I will zoom out a bit more. And then you can see that this parameter used to be here above -6 and used to be quite stable. And then some time ago, almost a month, not quite a month, but almost a month ago, something happened to the cable, some damage was done to the cable. And the power here, it jumped down. And from that point onward, it slowly started to degrade over time. Now, note that if you were looking at your anomalies tab here, you would have detected an anomaly at this point. But okay, suppose you were not looking at it, or at that time you thought it was something that would recover out of itself without doing anything. Well, you would still like to be notified about this trend down that you see here. Because right now it's maybe not yet a problem, but if it continues like this, yeah, you will lose all signal through the cable, right? Now, this optical power, this is expressed in dBm, and in theory, dBm that can go down to -infinity. So proactive gap detection can't really detect anything here because there is no lower bound that it can work with. So in order to have a detection in this case, we will have to help proactive gap detection a little bit. And we will do that by defining a threshold. And we will do that in the alarm template. So again, I will right-click this element, go to Protocols and Templates, assign alarm template, and then new alarm template. And let me again give it a name, thresholds, for instance. All right, I will monitor this parameter, and then I will fill in a critical low threshold here. And I will fill in quite a low threshold, so I will fill in -10. Oh, sorry, -10. And then I apply this. Now, nothing has happened yet because the parameter is not yet at -10, right? So no alarm is generated. But now proactive gap detection has a lower bound to work with. So it will notice that if this trend continues like it is doing now, it will soon hit this threshold of -10. Now, it takes a while before proactive gap detection will reevaluate its prediction and notice that there is now this threshold there that is going to hit. So I will do a little trick to speed things up. There is this button here, Generate Extra Data. And what this button does is it will push a few extra data points to this optical RX power metric. And that will trigger proactive gap detection to reevaluate its prediction. Yeah, this has the same effect as just waiting something like 5 or 10 minutes. But just for this video, to speed things up, I will press the button. All right. Now it's pushing the extra data points, and then proactive gap detection will reevaluate its prediction. And then if everything goes well, and yes, there it is, you have an extra suggestion event here in the alarm console, in the predicted alarms tab. And the suggestion event that is just generated is this one. It says a predicted critical low because it's going to hit the critical low threshold, and it is on the SFP monitor element. So again to my slides, which thresholds does proactive gap detection take into account? Well, next to the range limits, also the thresholds that are defined in the alarm threshold are taken into account. By default, only the critical threshold is taken into account, but there is a system-wide setting in the system center under System Settings, Analytics Config, and then Proactive Gap Detection. Let me just show this. So if you go to System Center, System Settings, Analytics Config, and then there is here Proactive Gap Detection. There is here minimum alarm severity. So this is the minimum alarm severity threshold that is taken into account. And currently this is critical, which is the default one. But if you select, for instance, minor here, then it will take into account all minor thresholds, all major thresholds, and all critical thresholds. All right. And next to that system-wide setting, there is also a setting per parameter in the alarm template that we will see in a few minutes. All right. Now, let me close the system center here. Now, you might say, well, why did I rely on proactive gap detection in this case of the SFP monitor here? I could also have defined a threshold of, say, -8, and then I would just have had a normal alarm. And yes, that's true. You can say that that is true. But the advantage of proactive gap detection is that you can define lower thresholds and that way hopefully avoid false positives and still get an early warning when a parameter is going to hit this threshold in the near future. So it's a way of avoiding false positives but still have early detection. And that is why I like this proactive gap detection feature so much, actually. Now, as I said, these events here that are generated in the alarm console, they are suggestion events. They are not real alarms, so they are not shown in the active alarms tab. And the reason for that is the same as with behavioral anomaly detection, because these are things that are detected automatically without explicitly configuring them. But just like with behavioral anomaly detection, you can make them into real alarms if you want to. And you can find it back in the same pop-up in the alarm template as we saw with behavioral anomaly detection. But let me show you another way to do it here, using feedback. So I like this detection here on the SFP monitor, so I will give a thumbs up on this one. And as before, there is a light bulb that appeared here, and that light bulb has the suggestion to improve my alarm template. So let me click that one, and I will go a little bit up here. And as you can see here with the proactive alarm settings, it suggests to check this check mark here. And what it will do is it will create an alarm. So an alarm instead of a suggestion event if the trend prediction goes towards a certain threshold. And then you can set the threshold, which it should take into account. In this case, there's only the critical low threshold. So that's the only option that you have. And then you can also select the severity of the alarm that will be generated. Now, it's a little bit confusing because it says 2 times critical here. So, but this severity is the severity that the alarm will get if the parameter is going towards this critical low threshold of -10, but it's not there yet. So personally, I would say, yeah, don't make it a critical alarm yet because it's not yet at the critical threshold. So I will make it a major alarm here. All right, and if I then press Update Alarm Template, then you see that the suggestion event has turned into a real alarm and is also shown here in the Active Alarms tab. All right. If you want and don't want to give feedback, you could also have gone here to the alarm template, then to Protocols and Templates, View Alarm Template, and then again all the way on the right in the Analytics column, there is a button, and that button opens the pop-up that we are now familiar with. And then all the way on the bottom in this pop-up, there is this setting that you could have checked here as well. Now here I can also show you if you would set more thresholds, say for instance -8 for major low and -6 for minor low, then in this pop-up we could have selected also other thresholds to take into account and create an alarm if the parameter is going towards the minor low threshold, for instance. All right, that is almost everything I wanted to say about proactive gap detection. There's just one final exercise for you. And this is also the exercise that you can upload here underneath the video. So I want you to go to the element AMS server. And that one simulates the disk space, the free disk space of a server. And as you might know if you have servers, the free disk space, it is a parameter that tends to go down over time. But you want to be notified when you will run out of disk space. So you want to be notified when this free disk space parameter is going towards 0, but is not yet at 0. And what I want you to do here in this exercise is I want you to create a warning alarm, so not a suggestion event, but a real alarm if this free disk space goes towards 0 gigabyte. And I can already tell you 0 is the lower range of this parameter, so you will not have to explicitly configure thresholds in the alarm template. And let me go to this element as well. So as you see here, AMS server. As you see, there is here a button, generate data, and every time you press that button, it will generate data for a new drive. And it's always the same data, so if you didn't get there on the first try, you can try multiple times to create this warning alarm. And if you succeed in doing that, you can take a screenshot of the warning alarm that you have in the alarm console, and then you can upload that here under the video. And if you do that, you will get some DevOps points. And that is all I wanted to tell you. So I will leave you with some links to some docs pages. And if you have any more questions, you can always reach out to us on ai@skyline.be or on the Dojo platform in the question sections or the features suggestion section. And that's all I wanted to say. So thank you for your attention and have a great day.